That would be a great place to start. So I think most people are familiar with DoorDash as a service, getting food delivery, or actually more than food, but in particular food. But from a business standpoint, like how should one think about it?
I think DoorDash wants to essentially help empower local businesses is the core to their mission. And so the company began with restaurants because they were numerous, and they began with food delivery because that was one of the most pressing problems for them. But the mission really is to do whatever we can to empower local businesses, provide services. Last mile logistics is something we're becoming proficient in. So that's an area where we're really making our mark.
So is that effectively a three-sided marketplace?
The food delivery is a three-sided, you're right. There's the merchant, the consumer, and the dasher. As we start to branch out into grocery delivery, convenience delivery, it becomes a four-sided where we introduce a picker as well. So yeah, that's right.
Interesting. So, what kind of what does machine learning and data science do in a three-sided or even four-sided marketplace? What are some of the problems that you guys tackle?
The really fun thing is that we were able to work on problems, both traditional consumer app problems, if you think about recommendation, ranking, search, pricing, all of those traditional consumer side problems, as well as then some of the newer sort of logistics type problems. When you think about companies like Lyft, who are matching a driver with the rider, we have those problems as well, matching the dasher with the order of the pickup. So we have all the pickup logistics plus the consumer app machine learning problems. And then again, all your traditional e-commerce problems, whether it's fraud detection, support, optimization, etc.
It's actually a really interesting way of thinking about the business, and perhaps it's obvious to some, perhaps it's less obvious to some. But like one thinks of DoorDash as something that physically moves people and product to different places. But like ultimately, would it be fair to say it's like a big software brain, which is like this logistics or delivery system that ultimately it's all software and allocation of resources against time and distance. Is that a good way to think about it?
I think we would like to think of ourselves as an infrastructure company. That's right, where we build products and services to help us in the things we're trying to do, but ultimately we get them to a stage of maturity and robustness through experimenting on ourselves, where we can then offer them as white label services to other companies in the same way Amazon built AWS, for example. That's definitely a nice way of thinking about what we're trying to build.
Great. All right, so I'd love to dive into the machine learning infrastructure part of it, like the tools and the software. So maybe starting with the requirements. I read on the engineering blog that some of the requirements that you guys thought about is you have a bunch of ML frameworks, you need to standardize and pick a few. Then you need to think about machine learning model lifecycle and then features. Maybe talk to all of those.
Sure. I think right at the start of a project is probably the hardest and most impactful part of the life cycle of the model. I think I prefer to call it sort of data-driven software, because it could ultimately be it could be something other than a model. Is actually identifying the right problem to work on, and framing the solution to actually solve the problem. And so a lot of work is done up front to really understand, are we trying to identify these particular categories, or are we trying to optimize metric A or B, or metric C with constraint metric D and Y? And so a lot of the time, that work has to be done up front. And then as well as that, what data do we have available, and maybe what data can we get, and what is the predictive power or optimization power of inserting this data into the workflow we have today to do that advanced measurement or optimization. So that's right at the sort of top of the stack, and oftentimes data scientists will work with their product managing partners or their operations partners to identify the right problem and solution. Then once we get onto the tech stack, it'll be a lot of
and then maybe while we're on models, so looks like you guys looked at a bunch of different things and then sort of converged towards a smaller subset of models. So just again reading through some of the stuff I've seen: XGBoost, LightGBM, CatBoost, obviously TensorFlow and PyTorch on the neural network side. Are those, is that the core of it, or are you always experimenting, trying new things?
Yeah, the motivation at the start was to how do we get everybody at the company onto the same centralized machine learning platform stack? So when I joined a year and a half ago, we'd already had models in search, fraud, logistics, etc., and they're all on their own stack. And so the first thing was, how do we bring everything onto one stack? So the first question was, okay, how do we build something quickly which solves most people's use case? And so we landed on using a framework that enables tree-based models. And we picked LightGBM for that after trying a few different packages, and also deep learning. And for that, we then used PyTorch. And so we started with those two core libraries. And we basically said to everyone, if you want to use the platform, you have to build to this. And yes, over time, we will add capabilities for other things. So it wasn't so much a constraint or a restriction. It was more of a prioritization. How do we enable the most people to migrate to a platform as quickly as possible?
Great. And I interrupted you where you were about to go into the infrastructure aspect of this.
Yeah, so once we picked a problem and solution, it's really then about grabbing our data. We use a Snowflake data lake. We use Python in Databricks and Spark to pull data in, build models. A lot of it will be off-the-shelf Python ML libraries like scikit-learn, or some of the Spark libraries. And then I think one nice thing we do is, instead of building a model and pickling it or whatever a conversion package you want to use, we commit the actual training script to our model library. And so each time the platform wants to run or create a new model, it runs the training script itself, which has configuration for bringing in data, creating features, training the model, and then it builds its model and it can push it to production to start making predictions. That's really good because it enables us to commit code rather than a model. And by committing code, we at that point can introduce the code review workflow in Git or whatever repository we're using.
I also saw that in your overall architecture, there is a feature store. Can you talk about what that is?
Yeah, we have
and maybe starting with what a feature is in machine learning for folks that may not know what it is.
Sure. So I suppose in traditional machine learning, a feature is a polished or aggregated combination of some input raw data. So for example, if I'm making a prediction on someone's health, I may take in their weight and height, but I might also transform the two things into some body mass index, like a BMI, which is a ratio of height to weight. And so this iterated input data is called a feature. And so that feature, we then take a lot of these features and we put them into a model, and they're combined in some way to produce predictions or output. And for us at DoorDash, we need a place to store these features, not only to train models on so we can make future predictions, but also in the moment of needing to make a prediction, we can call from this feature store. So it serves two purposes, for model training and for model prediction. And having a feature store is important to house this, be able to call these features very quickly, especially if they're for a real-time application like search, for example. We need to have those features available very quickly. And it's also important so that people can share useful features across different models and different use cases. So that's why we have a feature store.
Okay.
And it can get difficult when we're creating features that are aggregated on historical data. For example, what's my number of purchases in the past week versus a real-time feature such as how many times have I searched in the last 10 seconds, for example. And that creates different technology requirements.
And maybe compare and contrast this overall infrastructure against what you saw at Airbnb and Lyft. Are you seeing a convergence of the architectures being more or less the same, or is it, or do you see significant differences in terms of like how people build those machine learning sort of pipelines?
The themes are definitely similar. I would say at all three places, there was a desire for a centralized stack so that iterative improvements sort of helped all models. For the feature store, for example, there's a real tension between the data we use to train models offline and the actual data hitting the models when a prediction needs to be served. And there can be divergence between those two things. So you could imagine if I'm pulling my data from a warehouse to create a feature, then I train a model, and then in real time, I'm trying to compute that feature. They can actually diverge based on, I don't know, timestamps, rounding errors, precision, formats. And so a way to create a feature store whereby we can consolidate the training data with the prediction serving time data is a common sort of holy grail for all the companies I've been at in their pursuit. Another thing is being able to house models that can make batch predictions. So I can send a set of, for example, if I want to make a prediction for someone's life expectancy, I can send 100 sets of features for 100 people and make a batch prediction in one go. So make 100 predictions versus in sequence sending a person one at a time and making a prediction in serial. And so there's a real, again, holy grail is how do you create an ML platform that can do both simultaneously without having to duplicate code or duplicate the model itself. There's some themes like that which repeat.
Interesting. Let's switch to the team, the machine learning and data science team at DoorDash. How big is it? How many people? And what kind of people do you have on the team in terms of function?
So a year and a half ago when I joined, we had 5 or 6 people on the team. We're now at almost 30 people a year and a half later, and this year we want to double, so to get to 50 plus people. These data scientists, I wrote a blog post recently that went live, I think last Monday. We're looking for, of course, technical brilliance. You know, we have people who typically have a master's or PhD in a quantitative subject, plus some years of industry experience. So that's a given, and we have a very rigorous challenge before you come on site and have one-on-one interviews with us that test that. But what we really look for in the interviews as well is an ability to, or a real motivation to solve business problems rather than a desire to build cool models. I think that's well, and it's okay if you want to build interesting models and write interesting algorithms. That's probably best saved for academia or some research labs. For us, we're really interested in moving business metrics, and that's what we look for. We look for people who will do anything to move those business metrics. And over the course of a year, most of your time will be spent building interesting models to serve that purpose. But we have found a lot of people that are very technically gifted, but don't immediately gravitate to what is useful for the business. And so that's something we try to tease out. And it's probably unique to our interview process compared to other places I've worked, where we really test people's ability. to navigate business problems.
Yeah, how do you do that? How do you test the business part?
Really, we just borrowed interviews from other parts of the business. We've borrowed interviews from the analytics org and the operations org. So typical consulting, analytics type interviews where we give a nebulous business problem and say, this is something we're seeing. What do you think? What would you want to look at? What metrics would you care about? How would you frame a problem? What are some hypotheses? We go further back in the data science lifecycle of a problem to the real beginning, almost like PM-like questions, analytics type consulting questions. And they're very high signal. They've worked really well for us so far.
How is a team organized? Are they organized by project, by role, by function? They centralized? They all over the company? What does it look like?
So the data science team that I lead they report centrally up to through me. I have some managers up through them to me, but we distribute people to be embedded in cross-functional pods. So a cross-functional pod in a tech company typically looks like there will be a product manager who sort of sets the vision and strategy, and then there will be half a dozen engineers, an analytics person, a data scientist, maybe a marketer, maybe a designer, and together they co-design the roadmap for a given quarter, given a goal or metric set from above.
And you had this interesting theme around the democratization of machine learning, and I understand you created a machine learning council. I think you guys called it. Can you talk to that?
Yeah, some of the tensions I'd seen at previous places, and I'd also heard from others, is who should work on ML. Should it be data scientists or ML engineers or the AI lab? And I found a lot of these discussions, or I thought I could make these discussions and these conflicts unnecessary by essentially creating a set of principles for machine learning at DoorDash, whereby we say machine learning is a tool and we encourage everyone to be able to use it. We don't try and put restrictions on what people can do. What we do is put is to put hard lines, hard boundaries on what people are accountable for. So it is perfectly acceptable for anyone at DoorDash to build a machine learning model, but if they want to put it into production, they need approval or a review from someone like a data scientist or a machine learning engineer. So we try to divorce what someone can work on from what they're accountable for. The Machine Learning Council was a way to bring different flavors of machine learning together to co-build and co-strategize, and again, to diffuse some of the territorialness that can develop at larger companies. And so we have people from engineering, from the ML platform, from data science, and we'll add other people in the future. And it's a place for people to discuss ideas, discuss strategy, discuss hiring, discuss team composition, discuss roles and responsibilities. And it gives everyone a say at the table. And we meet every 2 weeks, we review technologies and we review priorities.
One more question from me, and then I want to start opening up to some of the questions in the chat. So when COVID hit, there was a lot of chatter around how it messed up machine learning models, which are ultimately all about prediction, but prediction based on a certain state of the world. And in a world that was dramatically different because of COVID, what was the impact on your models, and how did you go about solving that problem?
We saw some of those challenges as well, and our the first thing we did was make sure we were well set up for any of the outlier problems for consumers, merchants, dashers, and that we put any temporary fixes or caps or floors or multipliers on predictions that needed to for the sort of sudden step change in the environment. And then what we did as a second stopgap was we trained some of the look back for the training data. So whereas in the past, for an assignment algorithm, we might have looked back 4 weeks, we changed it to 1 week. And we then slowly extended that back to 2, 3, 4 weeks, but we shortened the timescales. So there was a lot of manual work to make sure predictions still made enough sense, so the customer experience didn't deteriorate terribly. But yeah, we saw a lot of feature drift, a lot of prediction drift, and it took a while to settle to a new equilibrium.
Great. All right. Let me, as promised, start to look at some of those questions. So maybe switching back to the infrastructure side of things, and in no particular order. Question from Glenn: is your feature store fully homegrown, or are you using a vendor product?
It's mostly homegrown. We're using some technologies like Flint for some of our real-time feature aggregation, data aggregation, but mostly it's homegrown. We try to avoid building things in-house and leverage third-party software when we can, but given some of the needs and some of the scaling requirements, oftentimes we do end up building in-house.
Question from Gedalia. Am I understanding correctly that instead of running Databricks on something like S3, you are running on Snowflake? Interested to hear more if that is so.
Apologies. Sorry. We run Databricks on S3, but we pull data into Databricks from Snowflake. So we have a connection between the two.
Interesting. And a question from me. Do you have two parallel stacks? Because I mean, there's presumably a whole stack around like BI and which is more centered around Snowflake, presumably.
Yeah, Snowflake is our data warehouse, and then many teams pull from that. So BI will pull from that to create data pipelines and dashboards at the end of that. And then we can also pull from those same tables in that data warehouse to build features and train models.
But you have the data warehouse on one side, and then in parallel you have S3 and Databricks, and both feed into machine learning. Or is that correct or no?
We don't pull much data from S3.
Okay.
We pull the data from Snowflake, and Databricks runs on AWS, and most of the data comes from Snowflake.
Okay. Interesting. Question from Sana. How do you ensure that your model can make the best predictions for new customers and use cases? Are real-time features given higher priority for training the model in this case, since you have limited historical data on new users?
New users can be difficult for us. If there's a strong enough use case for a different cohort or segment like new users, typically it'll make more sense just to train a new model rather than trying to shoehorn it into a general model. That's typically what we found. And again, the first thing will be to see, is there anything worth building a model around? If it's a new user and we don't have much information, probably isn't worth it for most use cases, and we should just apply some sensible rules.
Question from Sunyan. Very interesting to commit code to manage models. How would this scale for cases where the training time is lengthy and compute intensive, i.e. deep learning?
So then we'd probably change the frequency of retraining. So rather than every day, maybe we'd retrain once a week or once every 2 weeks. So it can still take however long, multiple hours to train. Then once it is trained and ready, it automatically gets pushed to production where it can serve and make predictions.
Let's see, there's a lot of good questions. Question from Wilson: do you have entity resolution problems, and how are you solving them internally or via a third-party solution?
Entity resolution problems. By this, I assume we're talking about sort of identity.
Presumably, yes.
Identity. So this comes up mostly so far on the fraud side, and we plug into a lot of typical vendors for getting signals on identity and credit cards, addresses, other attributes of identity. So yeah, we do use many of those.
Okay, maybe a couple more questions, this time more on the, excuse me, the team and skill side. Could you speak about the skills you needed to adopt during your transfer from academia and sciences to presumably a practitioner?
I can speak to DoorDash and some of the previous roles. I think so. Based on my experience in academia, my motivation was to find something interesting so that I could publish. That I remember being my motivation. And I think when joining a company, uh, we're signing a contract with the company to align our goals with the company's goal, which is typically its mission, and do whatever is necessary in the service of that mission. And so the first skill I would say is to create that mindset shift to what we're pointing our skills towards, which is advancing the mission and the metrics of the company. Other skill side, I say the soft skills are very steep learning curve. I found it very steep switching from finance to tech about how I interact with my fellow peers in product, in engineering, in operations, in marketing, how to do simple things like assume positive intent, be transparent, communicate frequently and clearly, articulately, be open minded, be curious, be encouraging. A lot of these social skills are probably the ones people coming from academia need. Yeah.
Great. And one last question. What are the hot areas in the tech stack or in domain knowledge that a new grad should try to get exposure to land a job at DoorDash?
I would advise people to have proficiency and awareness of a lot of the model types. So linear models, tree-based models, deep learning, and then to pick one area to go deep in, whether it's tree-based or NLP or vision or whatever it is. But have a broad awareness and then a real speciality in something. That'll serve you well in most companies you apply to.
Great, wonderful. Well, on this note, thank you so much, Alok. This was terrific. Really appreciate you dropping by Data Driven NYC and sharing a bit about your work, your infrastructure with us. Super interesting. So thanks again. Really appreciate it.
Thanks, Matt. Thanks for having me.